So now that we have our desktop set up, we're just going to dive right into wrangles. And in wrangles, we're going to be typing a lot of vex. And vex is vector expressions. So first I'm going to make a sphere. Set primitive type to polygon. Up the frequency. Then I'm just going to transform this by 5. And next we're going to drop a point wrangle. And then we're going to create our first attribute. And in order to do that, we're going to have to declare what that attribute is. And there's a lot of different types of attributes, but the first one we're going to deal with is a float. And we're going to say my first attribute equals 0. So now if I click off here, we can see that my first attribute is 0.0. And with the reason that it's 0.0 is that a float is a number that's divisible. So if I wanted this to be 1.5, it's now 1.5. But we're going to make our second attribute, and it's going to be an integer. And an integer, we'll see here, my second attribute equals 1.5. It's not going to do it. It's going to round down to the nearest whole number because an integer must be a whole number. For example, if you have a lot of points on this sphere here, let's say this point that I just clicked on is point number 1. Here's point number 2. There's no point number 2.5. It's a whole number. When you're counting things, you have to have whole numbers. So integers are very useful for declaring things like specific counts of things. So next we're going to make a third attribute, and it's going to be a vector. So vector my third attribute equals, and so if I put 1, it's going to create 3 different channels here, and they're all going to be 1.0 because these channels are defined by floats as well. So there are 3 channels here in the same way that position has 3 channels. So let's say instead of making it 1, we want to change the individual channel. So to declare a vector, you must use curly brackets. So I'll just make 2 up front, or an open and a closed. So now I can make this 1, I can make this 2, I can make this 3. And now you can see that each channel is different. And this is a very basic way to declare attributes. Another thing that you can do is you can create variables. So we can do the same thing where I can say float variable 1 equals 0.1. I can make vector variable 2. Again, I have to declare with curly brackets, 1, 2, 3. Int for integer, variable 3 equals 1. And so once I click away, you'll look down here and you'll see that none of these are showing up in my attribute editor. And that's because they aren't attributes. They're just variables that exist within this wrangle context that is not evaluated later down the chain. So this saves a lot in computation and just saves you from mucking up all the attributes that you're trying to save on whatever geometry you're affecting. Also, just to point this out, right down here it gives an error, and if I middle mouse over it, it says errors or warnings encountered during vex compile. Implicit cast from float to int. And so what that's doing is it's telling me that I've declared an integer attribute, and even though it's an integer, it sees that it's a float value, and it's just saying, hey, you made a float value here, so we're changing it to integer for you. So now if I make this just a whole number, that error goes away. So I think that vector attributes need to be explained a little bit more in depth and how you can manipulate them. So I'm going to just kind of undo that wrangle and create a new one. And then I'm going to create a facet node and pre-compute normals. And if we look up here, now I have normals. So if you're just starting out, a normal is just the direction in which a point on your surface is facing. It's very useful. I use it all the time for a lot of different methods. So it's really good to become familiar with normals and how to manipulate them. And we'll go further in depth into that later in the lesson. But really all you need to know right now is that a normal is just a line denoting a direction in which it's facing, and it's always from 0 to 1. If we look here in the geometry spreadsheet, you won't see anything greater than 1. You will have negative values, but those negative values will only go to -1. And so I'm just going to show how to manipulate each individual channel. So right now, if I wanted to, I could just say that the normal for every point in this is now facing up. So that means that in the Y channel, the up channel, that's the direction that everything's facing. And if I wanted to angle it slightly to, let's see, we'll go slightly to the left. I'll do 0.5. And you can see here that if you look at this gnomon right here, it's saying that Z is left in my viewport. And it's in the positive left. So I just added 0.5. So half of its direction is facing to the left, and it is also facing upward. But let's say that I wanted to change each channel individually without having to go into these curly brackets. I could individually say at n dot x equals 1. I could then say at n dot y equals 0.5. And then I could say at n dot z equals 0.25. And so this is how you just individually alter channels within an object. Another useful thing to know is that there are a lot of global attributes that exist in Houdini that you don't need to declare because Houdini already has created it or knows that it exists. For example, at P, I don't need to declare that it is a vector. Houdini already knows it, so I don't have to put a V in front of it. Same for normal. I don't need to put V at normal if I'm trying to manipulate it, or V at P. And there are a bunch of other very useful global attributes that we can use, such as I want to know how many points are in my sphere right now. So I could do I test equals numpt. Again, this doesn't need to be declared. It already knows what it is, and numpt is just the number of points. And so if I click down here, now I know that there are 1002 points in this sphere. We could also use the frame number. So I could do I other test equals at frame. So if I look here, other test is 1. If I start scrolling down, it's going to start counting up with the frame. Houdini knows what at frame is, and it could also work with time. What's interesting is that, so I declared this an integer, time is a float. So if I do F, then now we'll get increments. So time works in seconds instead of frames, so 24 will equal 1. Well, at 25 it will equal 1, since we started from 1 instead of 0. And there's a bunch more global attributes that we'll be using down the line, but it's just important to know that these attributes exist. And so while you don't see them all in this geometry spreadsheet, they do exist.